In this problem, we've been given a function f of x. We see that it's a quadratic function. We've been asked to find the equation of the secant line on this function from x equals 5 to x equals 11, and we've been asked to write it in slope-intercept form. So first, I'm going to use Desmos to help me do some quick evaluations and also to see this function and visualize this secant line. And we can actually graph that secant line in Desmos as well. So here I have defined f of x in Desmos. We see that it's an open-up parabola. We're interested in this function at x is 5 and x is 11. So I'm going to ask Desmos to evaluate f of 5. I see that it's 199.5. And f of 11, I see that that is 1072.5, so it's way off screen. If we want to, we can change the settings, change the viewing window, so it would allow us to see both of these points. I could plot the points, 5, 199.5, check label, and 11, 1072.5, also check label. In the settings menu, I'm going to have my x-axis span from -5 up to 15. That will definitely allow me to see x is 5 and x is 11. And my y window needs to go all the way up to past 1,000. So I'm going to go ahead and have it go from -100 up to 1,200. Okay, and I'll just kind of move this over so we can see it a little better. There we go. Now we can see the points of interest, x is 5 and x is 11 on our parabola. We're interested in the slope of the secant line, then we can find the equation of the secant line. Remember, a secant line is a line that intersects 2 points on the function. So first, I need to calculate the slope of this secant line. So in Desmos, I'm going to do y2 minus y1 over x2 minus x1. So that's f of 11 minus f of 5 divided by 11 minus 5. Notice I did wrap parentheses around the numerator and parentheses around the denominator. We get a slope of 145.5. So I could do 1072.5 minus 199.5 in parentheses divided by 11 minus 5. And we see we get the same result. So you could type them in either way, and we see that the slope of the secant line is 145.5. We can use point slope form to write the equation of any line. So I could do a y equals m, which is 145.5, times x minus x1, so I'm going to say 5, plus y1. When x is 5, the y value is 199.5. So this is point slope form. I'm going to go ahead and change that to a dashed line. So in purple, we have the secant line. I'm going to take that equation back to my main page. So I just came back to our original problem page here, and I've written the equation of the line in point slope form. This problem did ask us to write it in mx plus b form, slope-intercept form. So I can go ahead and distribute that 145.5. And then lastly, I need to add -727.5 plus 199.5. So that's the answer. Y equals 145.5x minus 528. If you like, you can go ahead and graph that. And we see that it lands right on top of the other line. I can turn it on and off, and you see that it lands right on top of the point slope form of the line.